Hello students, welcome to this session. I've just solved this JEE main test 72 and I'm doing this analysis here. So paper was not tough. I have regarded only 2 questions as tough, while we have 3, 6, 9, 11 were easy and then remaining 12 were medium. So it's a paper where you can score. There were 1-2 questions that could be difficult for you, like the one, let's say 18th, I suppose, that is regarding the Fresnel distance, which generally students don't remember. Otherwise the paper is good enough. Again, I say, for a student who's good enough in physics should get 60 plus, and a very good student should get 85 plus in this particular. So let's start the paper. First, see what is in the first question. The acceleration of electron in the first orbit of a hydrogen atom is okay. So as per option, it is in some h and r terms. So first of all, acceleration, because being a circular motion, it would be v square by r. V is not there because we are talked of Bohr model. We write mvr equals nh by 2 pi. So I can substitute the value of v from here, that nh upon 2 pi mr whole square upon r. So what it is, n square h square upon 4 pi square mr cube, and which is the option that I am getting like this. Yes, I have the option C like this. Next, the coefficient of restitution between a snooker ball and the side cushion is 1 by 3. Okay, if the ball hits the cushion and then rebounds at right angle to the original direction, then what is the angle made with the side cushion by the direction of the motion before and after impact? Okay, it should be before and after, so a single angle is given. Let me see what it is. Let's say this ball comes like this and it is going at 90 degrees, so it would be like this. So let's assume this angle is theta, which we have to find out. So this angle is 90, so this would be 90 minus theta. This is, let's say, initial velocity u, this is v. Now what we have, coefficient of restitution is 1 by 3. So first of all, that vertical component, let's say x and y, if I do that, vy is equal to v sine of 90 minus theta, that would be equals to 1 by 3 times u component downwards would be there, and that would be equal to what I can say, u sine theta. So what I get, v cos of 90 minus theta is equal to 1 by 3 u sine theta. Okay, cos theta, sorry, sine of 90 minus theta, that means v cos theta is 1 by 3 u sine theta. So first of all, from here what I can get, tan theta is equals to 3v by u, first thing. Next, because the x component will remain unchanged, so u cos of theta would be equals to simply v sine of theta. I can make it out. So from here what I can get, here what I am getting is this sine upon cos, that is again here tan theta is equals to u by v. So what we have, u by v, 3v by u. So if I multiply both, tan square theta comes out as 3 because u and v will cancel. So tan theta is root 3. That is what we are getting. So as per the option, it should be option B, the angle it makes with the side cushion before the collision. I can't understand what is after impact. This is before only I can make out. That is tan theta is root 3. Next one. A solid body rotates about a stationary axis so that the angular velocity depends on angle like this. Okay. Omega naught kr positive constant at moment t equal to 0, 5 was 0. Find the time dependence of rotation angle. So omega is given as a function of v, and you have to define that theta as function of t. So I can write omega as d theta by dt. That is what you generally write. That is omega naught minus k theta. I can write because that is theta. Phi is the rotation angle. So phi or theta, whatever you write. So d theta upon omega naught minus k theta is dt. This integration you all know. 0 to t, 0 to theta, so it would be ln of omega naught minus k theta with minus 1 by k coming here. So it would be upon omega naught. If you substitute both the values, that would be t. So what you will having, you will be having, I reversing it, omega upon omega naught minus k theta, or don't reverse it, no need to reverse it, do it only. It would be 1 minus k theta upon omega naught equals to e to the power minus kt. So theta would be equals to omega naught by k, 1 minus e to the power minus kt. As per the option, this is option C. So again, a basic integration, not tough for maths students, I suppose. Next, body cools from 50 to 40 in 5 minutes. Temperature comes down to 33.33 in next 5 minutes. What is the temperature of the surroundings? So going by this is the standard Newton's law of cooling problem. This is 50 to 40 in 5 minutes. And then 40 to 33.3 in next 5, that is in total 10 minutes. What you can write? So first of all, writing equation between these two and then between these two. So ABC, first between A and B. The equation says the drop is 10 degrees Celsius upon 5 minutes. that would be k times theta average. Theta average is 45 minus theta surroundings. This is first. The second one from B to C, again drop is 6.67. You can write it as 20 by 3. That would be convenient. I suppose upon 5 minutes, that is k times average. If you do, the average comes out as 36.67 minus theta s, that is 2. So now what you will have, divide both. If you divide both, this would be 30 by 20 is equal to 45 minus theta s. And if you do this, I can do this also as 30 plus 20 by 3. 30 plus 20 by 3, that would be, what I can say, 110 by 3. That would be, yes, it would be something like this. So multiply it. So 1110, 1100, 3 will cancel. Minus 30 theta s, wait a minute, minus 30 theta s equals 45 into 20, 900 minus 20 theta s. So what we have here, it goes 10 theta s, here it comes 200. So theta s is 20 degrees Celsius. You can directly make it out. Option B exactly is coming. Next, cyclic process is shown in the figure. Work done by the system, spelling mistake, during the cyclic process ABCDA is. So during the cyclic process ABCDA, work done by the system. So what we have, work done by the system would be simply the area, and it is clockwise, so it will be positive. And what is the area of the trapezium? That is half. Parallel side, this parallel side is 3, this is 1, so 3, 2 plus 1, sorry, 2 and 1 into the gap is 10 to the power 2. So what you have, 3 by 2 into 10 to the power 2, 300 by 2, that is 150 joules. So simple area calculation, not a tough one. So this is the fifth one. Next, cyclotron's oscillator frequency is 10 megahertz, radius of the D is 60, then the kinetic energy of the proton beam produced. So what we can say, frequency is given, so kinetic energy you need to find out. So the formula you need to remember, or if you let's say like me, I don't remember this much formula is. So what we know, radius is equal to mv by qb. So radius is equal to mv by qb, and that can be written as root 2 mk by qb. So kinetic energy comes out as q square b square r square by 2m. Okay, and what you have, this frequency. The frequency you write it is, what we type period is 2 pi m by qb, that is qb by 2 pi m. So qb by 2 pi m, what we have as the frequency. So putting in this value, I can put this q square b square as 4 pi square f square m square r square upon this is 2m. So 1m get cancelled. This is 2 pi square, what we have, 2 pi square m f square r square radius square. That is what we have got. So now substitute the value. 2 pi square, m is 1.67 into 10 to the power minus 27, f square 10 megahertz 10 to the power 7, that is 10 to the power 14, and 60, that is 0.6.36. I can write it. So what we have, 27 and 14, that is 10 to the power minus 13. This is also 10, so it is 10 to the power minus 12 into what we have, 1.67 into 2, that is 0.72. This is what we have in joule. So if it convert it, I know 1 mega EV is equal to 1.6 into 10 to the power minus 13 joules. So going by this, if you, this is almost like this, so it would be approximately 7 mega EV. From the data I can make it out 7.2 or 7 mega EV. So go for option C. So just remember these data. Next, if a person can throw a stone to a maximum height of h meter vertically, then the maximum horizontal distance through which the stone can be thrown. You remember maximum height will be when you throw at 90 degree. In this case, this h is u square by 2g, while in case of horizontal throw, maximum range is at 45 degree, and that is equal to u square by g, that is directly 2h. That's a very simple thing that being taught while studying the projectile. Water from a pipe of radius 5 cm strikes a wall at a speed of 5 meter per second normally and stops. The force exerted on the wall in Newton is. So radius is given, that means the area you can make out. So the force that we will talk about will be the momentum change, dp by dt. So that dp by dt, what we can write it as, dp by dt would be dm by dt into v, mass striking per unit time, and that would be rho dv by dt, volume striking per unit time, and that volume striking per unit time is AV. So that force is basically rho AV square. You know this. So density is 10 to the power 3, area is pi into 5, that is 1 by 20 meters square into V square, that is 5 square 25. So what we have, 1000 into pi into 25 upon 400. So these two zeros goes. So what we have, 250 pi by 4. So 250 pi by 4 is 62.5 pi. I can directly take it option C. Next. The radioactive isotope X with a half-life of 10 to the power 9 years decays to Y, which is stable. A sample of rock was found to contain both the elements in the ratio 1:7. I have always taught my student look for the ratio 1:1, 1:3, 1:7, 1:15. 1:1 means 50% decay, that is half-life. 1:3 means 1/4 remains, that is 2t half-life. 1:7 means 1/8 remains, that is 3t half. So it is 3t half. You can directly take it. So all my students who have been taught by me should be able to do this without doing any major calculations. The ratio of kinetic energy at the mean position to potential energy at a/2 of a particle is. So kinetic energy at mean position, you know, is complete energy, half m omega square a square. And potential energy at a/2 would be half kx square, that is half m omega square. a/2 whole square is a square by 4. So clearly that ratio is 4:1. Nothing to be very special about it. Next. A silver ball has a radius 4.8 centimeters suspended by a thread. UV light 200 nanometer incident, during which total this energy falls. Assuming that on an average 1 out of 10 to the power 3 photons incident, the ball is able to eject an electron, then the potential of the sphere is, first of all, number of photons striking would be 1 into 10 to the power -7 upon each photon energy, and each photon energy is hc by lambda, that is what you can say 1240 upon 200 eV, that is 6.2 eV. So converted 6.2 into 1.6 into 10 to the power -19. So number of photons coming out would be 10 to the power 12 upon 6.2 into 1.6, that is roughly 16 2s are 32, 16 6 are 96, 99.2. I can approximate it as 10 to the power 10. Okay, so 10 to the power 10 photons are falling. So the number of electrons that would be taken out would be 10 to the power 7, because out of 10 to the power 3 1 is successful. So 10 to the power 7 electrons goes. So potential would be kq by r, that is k number of electrons into electronic charge by r. 9 and 10 ki power 9, number of electrons is 10 to the power 7 into 1.6 into 10 to the power -19, and radius is 4.8 into 10 to the power -2. So this is 3, this is 3. So what we have 9 and 7, what we have 9 and 7 as 16 and 2 18. So it would be 0.3. I'm getting it should be 3, I suppose. There must be some calculation thing that I have gone wrong, I suppose. Let me do it again. 9 and 7 16 and 2 18. So I'm missing something. It is 0.3 for me that is coming out, but I can. Okay, let me check. Okay, here I have done this mistake. This is 9.92, so this should be 10 to the power 11. So this is 10 to the power 8. So now our problem is solved. It would be 3 volt. So the digit was helping us, but yeah, we should have done it more properly. Yeah, next one. The pressure inside two soap bubbles are this and this. The ratio of their volumes will be, what do you know? The pressure, that is the excess pressure that we say for a soap bubble, delta P is 4S by R. So what I can say, this delta P1 upon delta P2 is R2 upon R1. That is what I can make. That would be delta P1 by delta 2 is 0.02 upon 0.03. That means R1 by R2 is 3:2. And now the volume would be V1 is to V2 is R cube. So that is 27 by 8. So no issues in this. You can directly go for option D. Next. We have a light beam of diameter √3r incident symmetrically on a glass hemisphere of radius r and of refractive index √3. The radius of the beam at the base of the hemisphere is going to be. Okay. Now this is different from the question where the beam was very small width. The width is very large. So first of all, I know this would be the normal at the point of strike. Let's say let's call it A, let's call it B, both will be symmetrical. So at A, first of all, let me find the angle. So how can I find this angle that it makes with this normal? So to find this angle, let me draw it like this. This angle would be, let's say, incidence angle. So let's call it I. So this will also be I. Now this thing is, you are given as √3 by 2, and you know this is equal to R. So what I can make out? I can make out sine of I is equal to this distance is √3 by 2R divided by R, that is √3 by 2. So this I comes out as 60 degree for you. So by going by the Snell's law, so 1 into sine of 60 would be equal to √3 into sine of R, sorry. So what is sine of R here? Sine 60 is √3 by 2 upon √3. That comes out as 1 by 2. So R would be 30 degree. So because it has entered into a denser medium, it will bend towards the normal. So bending towards the normal, it will now go like this. It will now go what we have, this was the normal here, so it will go like this. So now it comes like this, and this angle you say will be 30 degree, sorry, with the normal, and this is my mistake, let me draw it again. So because it is 30 degree, so this is the normal. Don't draw this line, no need to draw this line, just we need to remember this thing. So with the normal now it will make, instead of 60 degree it will make 30 degree. So this angle is going to be 30 degree for you. So now it strikes here. So if it strikes here, now I need to find out what this value is particularly going to be. So now if I check this, I need to be very careful, and I know this angle was 60, so this angle is also 30 degree, so that might help me. So let me go for this one. Let's call what I called it A, let's call it P, let's call it Q. So in the triangle APQ, angle P is 90 degree. Now what I can draw is 10 of 30 degree would be equals to this QP upon this distance, and this distance you already know is equals to R cos 60, that is R by 2. So that is 2 QP by R. So QP value comes out as R by 2 root 3. So it is R by root 3. So that means this remaining distance would be root 3 by 2R minus R by 2 root 3, and the width would be double of that because of symmetry. That distance would be there also. So that would be what we have, root 3R minus R by root 3. So what it comes out as 3R minus R upon root 3. That is what we have. This is 2R by root 3. Okay, actually I have calculated the diameter if I take the 2. Okay, so I need not to take this 2. This is basically diameter here, so the radius would be R by root 3. So I was lucky that no option was there, otherwise I would take for diameter. So it is R by root 3 because we have to check for the diameter, not we have to check for radius. Yes, this is option A. So a nice question. Next, a disk of 2 kg, radius 0.2 meter is rotating with an angular velocity 30. Okay, passing through center perpendicular to plane. If a mass is stuck on the periphery of the disk, then its angular velocity will become, so it's an angular momentum conservation thing basically, because you assume no external torque. So initial angular momentum would be I disk into omega naught would be equal to I of system finally into omega of system finally. So disk omega because it was perpendicular axis, it is mr square by 2 into omega naught. That would be equal to mr square by 2 plus additional mass, let's say m into r square because it is a point mass, into omega of system. So omega system now becomes mr square by 2, that is 2 into 0.2 means 0.04 by 2. Omega naught was 30. Again this is 2 into 0.04 by 2 plus mr square, that is 1 by 4 into 0.04. So this 0.04 term I can directly take it out. So it is 30 and it is 1.25. So 30 upon 1.25, or you can say 30 into 4 by 5. That is what you can write. So this is 5, 6, 6 4s are 24 radian per second is going to be the option A. Next, for a transistor, the current amplification alpha, that means it is common base, or alpha you can also write it generally. For common emitter it is beta. It is connected in C, not CB. The change in collector current when the base changes by 6. So first of all, you know alpha is delta IC by delta E. That is what you write. Now the base current change is given, so and you have to find the collector current change. So you can write it as delta E as delta IC plus delta IB. That is one and the same thing. You know this I is equal to IB plus IC. So 0.8 into delta IC plus 0.8 into delta IB equals to delta IC. So delta IC is going to be 0.8 times delta IB upon 0.2. That is what you are going to get here. So what you are going to get here, this is 4 times delta IB. That would be 624 milliampere. 6 4s are 24. Option C. Next one. If the average kinetic energy of a molecule of hydrogen gas at 300 Kelvin is E, then the average kinetic energy of the nitrogen gas at the same temperature is going to be same, because for all the energy remains, the average energy at any temperature remains the same. So hydrogen, nitrogen also both are diatomic, so no difference in any respect we have. The sides of a rectangle are this and this. Taking significant figures into account, the area of the rectangle is, so this has 3 figures, this has 2 figures, so the final answer must be of 2 figures. So go for 84. That is the only thing that we should do. Next, For what distance ray optics is a good approximation when the aperture is 4 mm and the wavelength of light is this? This is an important question. Generally people don't remember this. You have to remember that Fresnel distance formula, that is ZF ray optics validity, is still a square by lambda. So a is 4 mm, so 4 into 10 to the power minus 3 square, lambda is 400 into 10 to the power minus 9. So you have 16 into 10 to the power minus 6. You can write it as 4 into 10 to the power minus 7. This is 4. So this is 40 meters. So up to 40 meters ray approximation is valid. After that it is not. So just remember this formula. This is given in your NCERT book in wave optics chapter. A pipe closed at one end has a length 83. The number of possible natural frequencies of air column whose frequencies are below 1000 hertz are. Okay. So because it is closed, the available frequencies that I can write is 2n plus 1 V by 4L. So first of all, what is this V by 4L? This V by 4L thing would be 332 upon 4 into L. So L can be varied. So maximum L I can make out that is what it could be. Pipe closed at one end. Okay, length is what? 83. 83 you can write it as 0.83. So if I do this, this is 83. If I do this is 83 forza. So that is 400 by 4, that is 100. So what we can have 100, next we have 300, next we have 500, next we have 700, next we have 900. Now it will cross 1000. So it could be 5 possible values are there before that. Next. A particle of mass m moves along the quarter section of the circular path whose center is at the origin. The radius of the circular path is a. A force acts on the particle where xy denotes the coordinates. Calculate the work done. This by force in taking the particle from A to B along the circular path. Okay. Now we know in any small displacement we write work done as F dot dr. So if I do that F dot dr, and in general what you write it as yi cap minus xj cap, dr you generally write as dxi plus dyj. So what you get? Y dx minus x dy. So work done would be integration of this thing. So you have two integrations. You have y dx and you have x df. Now you need to get x and y as a function of each other. So what do you remember now? What you basically know, that because it is on circle, x square plus y square is always going to be a square. So you can put y in terms of x and you can put x in terms of y, or more smartly if you observe here, it would be 2x dx plus 2y dy is equal to 0. So here I can directly get this x dx plus y dy is 0. So now you can do this. Otherwise you would directly put it y as that and you can do integration because you all are smart enough in mathematics. But let's say, let me simplify this, or what I can write now, y dx. I convert this y dx into, let's say this dx I can write as minus y dy by x minus y dy by x, and this is minus x dy. So it would be simplified y square plus x square, that is minus a square I will get here, and I'll get dy by x. So again you have to do this, it's not going to be easy. So now what you will do, this x you have to substitute in terms of y, like this x square is going to be a square minus y square under root dy, and do this calculation, and the y is varying from 0 to a. So you are smart enough to do this. If you do this, it would be minus pi a square by 2. I'm not doing it. Do it for yourself. You are maths student, far better than me in integrating it. But it's a tough one. In a hydrogen discharge tube, it is observed that through a given cross section, these electrons are moving from right to left and protons are moving from left to right. So both the currents will add up because both are going opposite. Let's say electrons goes from right to left, protons goes from what we say left to right. So both current would be in this direction. So both will add up, IE plus IP, and this is per second what we are given, are moving per second. Okay, so what we'll have, electron current would be 3.13 into 10 to the power 15 into E, plus it would be 3.12 into 10 to the power 15 E. So taking E as common, 1.6 into 10 to the power minus 19, this comes out as 6.25 into 10 to the power 15. So what we have, 6.25 into 1.6, you remember 6.25 into 1.6 will be perfectly 100, I suppose. Let me try. 16 5s are 80, 16 2s are 32, and 8 40, 16 6 are 9600. Okay, so 10.00 into 10 to the power minus 4. So it is 1 milliampere for sure. So the answer is going to be 1 here. Next one. In a magnetic field 0.05 of Tesla, area of coil changes from 100 to 1 to 100. Without changing resistance, the amount of charge that flows, you know, Q is equal to N delta phi by R, if you remember. So N is here 1, delta phi would be B delta A, that is 0.05 into 1 centimeter square, that is 10 to the power minus 4 upon 2. So this comes out as 5 into 10 to the power minus 6 by 2, that is 2.5 microcoulombs. So directly you can do this, 2.5. Next, total electrostatic energy stored in both the capacitors will be here. So what you have, the potential difference of 3 is maintained. So 3 is maintained. So what I can say, I can, let's say, take both the means 3. C equivalent is 18 by 9, that is 2 microfarad. So energy would be half into 2 into 10 to the power minus 6 into V square, that is 9. That is 9 into 10 to the power minus 6 joule. So again, an easy one for you, just trying to confuse you, but it's an easy one. Next, body is released from a great height, falls freely towards the earth. Another body released from the same height exactly 1 second later. The separation between the two after the release of the second body is 2 seconds after the release of the second body. So for the second body has traveled, y2 would be half g into 2 square because it is dropped. So it is what you can say 5 into 4, 20 meters. But for the first body it would be 3 seconds because 1 second later, so half g into 3 square, that would be 45. So gap you can make it out is equals to 25. Okay, I have taken g to be 10. If I do this, you have to convert it into g. So just put it into g only, it is 2g, and this comes out as 4.5 g. So the gap would be 2.5 g. G is 9.8. 25 8s are what we have, 200. 25 9s are 225 and 22 45, so it is 24.5. So go for 24.5 meters for this particular case. Next one, if a new planet is discovered rotating around the sun with the orbital radius double of Earth, then what will be its time period? We know t square proportional to r cube, nothing else. So radius is doubled, so t proportional to r की power 3 by 2. So 2 to the power 3 by 2, that is 2 root 2 times its time period in Earth's days. Okay, Earth days 365. Okay, root 2 is given, so that becomes 2.8 into 365. So 28 5s are 140, 28 6s are 168 and 14, that is 168 and 14 would be 182. 24 28 3s are what we have, 84 and 18, that is 10. 84 and 18 is 102. So it would be 102 or 103. Let me check. 28 6 are what I had, 140, 168. So 168 and 14, 182. 28 3 is 84 and 18, that comes out as 1022 days. So here it should be 1022. They have given 1032, but it should be 1022 as per the data. I think they have taken that 1.41. Let me check what I have taken. 1.41. So if I have taken it 1.41, it would have been 2.82 and then 1029.3. Then also the answer would have been not exact 1032. So no issues in Earth's days. So Earth days 365 days. So with 1022 days I can go.